Hello, geometry class. How are you guys today? We're going to continue learning about circles, all right? And we have a lot more words. So there's a lot of vocabulary with circles because when we first started learning about triangles, we had to learn a lot of new words about triangles as well. And now that we have started learning about circles, we have to learn a lot of new words to help us describe the circles. So last time we talked about a circle, we talked about the center, the radius, a diameter. We talked about a secant line, a tangent line, points of tangency, and all of those different things. All right. Now, today, excuse me, today we're going to talk about parts of a circle. All right. So I'm going to start by drawing a circle over here. All right. So here we go. We got oh no, I don't want it to be so thick. That is a thick circle. Let's make it thinner. All right. So, yeah. So let's start with this circle. Okay. So I'm gonna draw a circle over here. All right, like that. All right, and then I'm gonna mark its center right here. All right. And I'm gonna give this center. I'm gonna give it a name. This point. I'm gonna give it a name. I'm gonna call it C. All right. All right. So that's C. Okay. Now, I didn't mention this in last week's class about circles, but when we name a circle, usually we name it by its center. So, for example, we would call this circle, we would call it circle C. All right, this is circle C. Or sometimes instead of writing the word circle, we draw a circle with a dot in it. All right, and then next to it we write C. And we say this is called circle C. So this is the name of the circle. All right, it's called circle C. Okay? All right, and today what we're going to talk about, parts of a circle, a piece of the circle. So let me change my color right here. So if I just drew part of a circle from here, and then we go down to like right here. All right, so this part of the circle. All right, so I started, maybe I start right here and I go to here. All right, maybe I'll give this point a name. I'll call it A. And I'll call this point right over here B. All right. All right, this is a part of a circle, right? It's just a piece of the circle. And we give this a special name. We call it an arc. A-R-C. Arc is the name that we use for a part or a piece of a circle, all right? So, AB here is an arc. And when we write the name of this arc, the way we do it is we write A, B. Now, if it's a line segment, we put a line segment on top. If it's a line, we put a line with arrows on it. All right. If it's an arc, what we do is we draw a little arc on top, just kind of like this. All right. Kind of like a little hat on top. All right. A curved line on top. That means arc AB. All right. So arc AB is a part of a circle. All right. Now, if you look at this arc, you'll see that I can draw a line from B to C. Actually, let me do it using the line tool. All right, so here, let's do a line. All right, so I can draw a line from here. Oh, too thick again. I thought I already changed that. All right, one more time. All right, we start here at B, and we go down to C. All right, so we have a line. All right, and I can also draw a line from A to C. All right, from here to here. Okay, and it makes this little shape here. All right, so we have a line from here to here, a line segment, and a line segment, and then the arc. It makes a shape kind of like a piece of pizza or something like that. Okay, now you should note that this line segment from B to C is a radius, right? Remember, what is the definition of a radius? We learned it last time. It's a line segment from a point on the circle to the center, all right? So B to C is a radius. Also, A to C is a radius, right? Because it goes from the circle to the center, all right? Now, you will also see that, let me change my color here, that this makes an angle here, all right? This makes an angle, all right? All right, and this angle is what we call a central angle, all right? It's a central angle. So we're going to write down the definition of central angle right now. It's an angle whose vertex is the center of a circle. Okay? And we're going to stop there. All right, so you can see that the vertex, remember, in an angle, the vertex is the point where the two line segments meet. All right, so this line segment meets and this line segment meet right here at C, and that's called the vertex. Now, the vertex here is the center. It's point C, right? So that this angle is called a central angle because the vertex is the center, all right? Okay, next. Now, we already said that this blue piece right here, the piece of the circle here, we call it an arc, all right? So now we're going to talk about the difference between a minor arc and a major arc, all right? All right, so this is going to be a little bit hard to type because we're going to have to use some special words. So what is a minor arc? It's the points on circle C between A and B if the angle, if angle ACB is less than 180 degrees. All right. All right. So that's the definition. Is the points on circle C. All right. So this is circle C. These are points on circle C, right? They are between A and B, but the angle ACB has to be less than 180 degrees. If it's more than 180 degrees, then it's not a minor arc, all right? Then it becomes what we call a major arc, all right? So if it's more than 180 degrees, then it's a major arc. Now, minor means small, major means big, right? All right, so if this arc is bigger than 180 degrees, then it becomes a major arc. But if it's less than, it's a minor arc, all right? So what is the definition of major arc? Well, we're just going to write it's the points on circle C. Oop, I wrote circle wrong. Circle C that are not on the minor arc, all right? All right, so all of these points, these red points out here, they are not on the major arc. I mean the minor arc. So the minor arc here is AB. So all of these points that are not on that blue part are the major arc. So these are this big red part right here, kind of like Pac-Man, all right, is the major arc, all right? So the blue is minor arc, the red is the major arc. All right, now what is a semicircle? All right, let's write down the definition. A semicircle is an arc with endpoints that are on a diameter. Okay, so what does that mean? Well, in order to do this, I'm gonna draw another circle real quick. All right, so let's draw another circle. All right, here's a circle. I'm going to give it a center. Let's put the center about right here. I'm going to give this center a name. I'm going to call it D. So this is circle D. All right. Now I'm going to draw a diameter. All right. What is a diameter? Well, we learned that last time. Do you guys remember what a diameter is? All right. Here, let me switch to this. What is a diameter? A diameter is a chord, which means a line that goes from one point on a circle to another point on a circle, but it has to go through the center. All right, so let's start here. And I'm going to draw my chord. It goes through the center to the other side. So this green line right here is a diameter. All right, I'm going to give a couple more names. I'm going to say that this point right here is point E. And I'm going to say that this point right here is point F. All right. So this line segment EF is a diameter. And a semicircle is an arc that has endpoints on the diameter. So I'm going to draw my arc in blue. So if I start here at E and I draw an arc, means all the points on the circle here. Kind of hard to draw. Oop, don't worry about that. All right, this blue thing right here. All right, this arc is a semicircle because the endpoints are on a diameter. All right, so it cuts half of the circle. Remember the word SEMI, semi means half. All right, so this is a semicircle. It's half of a circle. All right, this blue arc is a semicircle. All right, next, what is the measure of a minor arc? Okay, we're going to write down another definition real quick. All right, what is the measure of a minor arc? All right, it's the measure of angle ACB, where A and B are the endpoints of the arc, and C is the center of the circle. All right, I'm just going to write center. All right. So the measure of angle ACB, where A and B are the endpoints of the arc, so A and B are the endpoints of the arc, and C is the center, well, then the measure of this angle is the measure of the arc, of the minor arc. All right. Okay, see that? All right. A, B, C. So this angle is called the measure of the minor arc. So if in your homework, or in a second we have some examples, if it says find the measure of the arc, or find the measure of the minor arc, you are trying to find this angle measure. You are not trying to find the length. Some people get that mixed up. They think, oh, the measure of the arc is how long is the arc. No. The measure of the arc is the angle of the arc that it makes right here. All right. So AB, the measure of it is this angle. All right. Next, what is the measure of a major arc? Well, it's just going to be 360 degrees minus the measure of the minor arc. All right. So remember, in a circle, to go from here all the way over around in a circle, it's 360 degrees, right? So if we want to find the measure of the major arc, which is this red line here, all right, we're just going to go 360 degrees minus this. all right, minus this measure. And that will give us the measure of the major arc. All right, next. All right, just a couple more things. All right, adjacent arcs. What are adjacent arcs? Adjacent arcs are two arcs that share or that intersect, let's just say intersect at one point only, all right? So if two arcs intersect at one point only, then they are called adjacent arcs, all right? So what does that look like? Well, again, let's draw it, all right? Up here, I'm going to draw another arc. Let's say we have a point over here. Let's call this point G, all right? And let's draw an arc from B to G, all right? So here we go. We got our arc. Ooh, it's kind of hard to draw. But anyway, you get the idea. Here is our arc from B to G, all right? Now, these two arcs, arc AB and arc BG, they are adjacent because they intersect at one point. What one point do they intersect at? B, right? They both have B in them, all right? So that's why they are adjacent. It just means they are two arcs that are next to each other, right? All right, next. These next two words don't really have to do much with arcs. Well, actually, the next word doesn't have much to do with arc. The one after it does. What are congruent circles? Congruent circles are circles that have the same radius. All right? If two circles have the same radius, then they are called congruent circles. All right? So if I draw two circles and they both have the same radius, then we say these are congruent. All right? They are the same. They look the same. All right? All right. Next, congruent arcs. What are congruent arcs? Congruent arcs are arcs that have the same measure and are on congruent circles. All right? So if we have two arcs that are on two circles that are congruent, that means two circles that have the same radius. If their measure is the same, and remember, measure is the angle here, that means the two arcs are congruent, all right? We'll talk about that more later, all right? And similar arcs is our last word that we need to know. Similar arcs are arcs that have the same measure. All right, so if two arcs have the same measure, but they are not on two circles that are congruent, then they are similar. Let's look at an example of that. All right, let me draw another line. Actually, a line. All right, I'm going to draw a line from here, start here, up to here. Okay, another radius. All right. Now, if I have an arc like this, all right, and I measure this angle, all right, and let's say that this angle here and this angle here are the same, all right, let's call this angle, let's say it's 30 degrees. And let's say we measure this one, it's also 30 degrees, all right. Well, then here we're going to have an arc, all right, let me draw the arc. All right, here we have an arc from E to, let's give this point a name. Let's call this H, all right? So here we have an arc, EH, all right? And up here we have an arc AB. Well, because these two arcs have the same measure, 30 degrees, 30 degrees, that means they are similar arcs, all right? They are similar, right? Because they have the same measure. Are they congruent? No, because this radius here and this radius here are probably different. Maybe let's say this one is 15, and let's say this radius here is 10. All right, these two radii are different, so that means they are not congruent. They would have to be the same if they're going to be congruent. Okay? So those are all the words that we need to know. Central angle, minor arc, major arc, semicircle, blah, 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 blah. All right? Now, we're going to look at a couple of, actually, we're just going to look at one rule. The other rules here are pretty obvious, all right? So we're going to look at one rule here, the arc addition postulate. And it just tells us that if I want to know this arc from A, B, C, all right? If I want to know what is the measure of this arc, right? Well, if I know the measure of AB from here to here, and if I know the measure from B to C from here to here, well, A to C is going to equal the measure of A to B plus the measure of B to C. All right, so that's what this is saying. It's saying, this is the red line from here to here, measure of A, B, C is equal to the measure of AB, which is the blue one, AB, plus the measure of BC, which is this yellow one. All right. So this equals this plus this. And we're talking about the measure. And what is the measure? Remember, the measure is, if we have the center here, it is the angles that they make. All right. So this angle plus this angle is going to equal this angle all the way over to here. All right. This angle plus this angle equals the whole angle. All right. That's what this means. All right. Now, these other theorems, these other rules, we don't really need to worry about them. All right. Congruent circles, it's just saying that two circles are congruent if they have the same radius. Now, we already said that in the definition. All right. If they both have the same radius, then these two circles are congruent. All right. Don't worry about this one for now. And this one just says that all circles are similar. All right. Remember what similar means? It means the same shape, but maybe not the same size. All right. But all circles are the same shape. It's not like triangles. Triangles, you can have one triangle that looks like this and another triangle that looks like that. All right. They're not the same shape. All right. One has a really small one here, and it's isosceles. All right. The other one's not the same. All right. So, but circles are always similar. They're always the same shape. All right. Okay. So we're going to move on and do a few examples here. It's not very hard. All right. These are all pretty easy. All right. So I'm not going to go through all of them, but let's look here. A, B. All right. This one, first of all, let's read the directions. It says, we need to say, is it a major arc, a minor arc, or a semicircle? All right. Now remember, what is a major arc? Major arc is that it's bigger than 180 degrees. Bigger than 180 degrees. What's a minor arc? Minor arc is smaller than 180 degrees. And what's a semicircle? Semicircles means it equals 180 degrees. All right. From here over to here is 180 degrees. All right, so first we're going to start with AB. Well, that's going from here to here. So it's this arc right there. All right. So the question is this major, minor, or semi? All right. Well, it is clearly less than 180, right? 180 would be half of the circle. Well, this is not half the circle. This is less than that. So this has to be a minor arc. Minor arc. All right. Now, we also need to find the measure of the arc. Now, how do we do that? Well, that would be very difficult if they didn't tell us this. All right. AC is perpendicular to BE. Well, this is AC, this line, and this is BE, they are perpendicular. That means they make 90-degree angles. All right, this is a 90-degree angle. This is a 90-degree angle. All right. All right. Now, because we know that, we can see that the angle, what is the measure of the arc? It's the angle that we make like this. All right. And that is 90 degrees. So the answer here is 90 degrees. All right. And the way we write that, please write this correctly. Don't just write 90 degrees. Please do your homework properly. Write the measure of arc AB equals 90 degrees. Okay? The measure of arc AB equals 90 degrees. All right, next, let's look at ABC. Well, ABC is from here all the way over to here. All right, so we're going to add this part. So it's this whole thing. All right. All right, so this whole half of the circle then. All right, now we know that A to C is a diameter, right? Because it goes through the middle. It goes through the center, all right? So because it's a diameter, that means this has to be a semicircle. And a semicircle is always 180 degrees. So this is a semicircle. So we're going to write semicircle. I can't write it well. Oh, this is, I should have wrote minor arc. All right, not just minor. All right, minor arc, semicircle, and all semicircles, the measure of the semicircle, so I'm going to write measure of ABC, put the arc sign on top, is going to be 180 degrees. Okay. Next, let's look at ABD. All right, so now we're going from A to B, and then we're going to go all the way to D. All right, well, we already said ABC is 180, right? From here to here. But then we have another 40. But these are adjacent, right? A, C, and then D, that's adjacent, right? So that means, according to the rule that we just learned, that adjacent arcs, you can add them together, all right? And we know that this one is 40 degrees, all right? So this is going to be 180 plus 40, which is 220. So it's going to be the measure of arc A, B, D, put an arc on top, is 220 degrees, right? Because we just add them together, all right? And next, we need to say, is it a major arc or a minor arc? Well, it's bigger than 180, so this is a major arc. Major arc. Okay. Next, we'll do one more example. Actually, I'm going to go, let's do this one. B-A-C. Okay, let's do this one, D-A-B. All right, D-A-B. I'm going to mark this in a different color. So we're going to start at D, and we're going to go all to A, and then all the way over to B. All right, D-A-B. All right, good. Well, A to B is 90, right? We already know that, all right? But what about A to D? Well, we don't know that yet, but it's easy to find out because we know that from A to C is half of a circle, which is 180. And this part here is 40. That means this from A to D has to be 180 minus 40. So that means it's going to be 140 degrees. This angle right here, from here to here, is 140. So that means from D to A is 140, and from A to B is 90 degrees. So the whole thing is going to be 140 plus 90, which is 230. All right, so we're going to write that down. We're going to say the measure of arc DA AB, put the measure of the arc is 230 degrees because 140 plus 90. All right. And is it major, minor, or semicircle? Well, it's bigger than 180, so this is another major arc. Okay. Now, tonight's homework is going to be pretty easy. I'm just going to give you some problems like this where you need to tell me is it a major, minor, or semicircle, and you need to find the measure. All right. That's your job tonight. Please let me know if you have any questions. See you next time.